Good day, everyone. I'm here to present the project entitled DLI and PPDF throughput of the solar and AI-based smart lighting applied on illumination stratums. So I'm Myrtle S. Bernardo from Bulacan Agricultural State College, Philippines. So the United Nations aspire us to ensure that no one is left behind, reducing all forms of poverty, preventing inequality, and preventing climate change with the passage of its resolution on the SDGs by 2019. Food security is a state in which everyone continuously has physical, social, and economic access to an appropriate amount of food that is nutritious, safe, and fits their dietary needs for their active and healthy living, as stated by the International Food Policy Research Institute in 2021. So daily light integrals. Are your plants receiving a right amount of light? So the light is the most important factors growing in any crop. But how are you ensure that your plant are receiving enough light? There is a way to measure the light intensity received by your plants. And the photosynthetic photon flux density or the PPDF, it occurs in a large portion of the electromagnetic spectrum, which is a fraction of spectrum it's utilized by plants for photosynthesis. The wavelength of the light spectrum from 400 to 700 are called the photosynthetically active radiation that can be measured in mole as reference, as you can see in the graph, that the LED has its high intensity bulb lighting. So the objective of the study took into the automation of the controlled sunlight wavelength using the LED, use treatments to use in high value crops like lettuce for the indoor farming setting, optimizing its uh, it's the hydroponic systems. So it also provides an artificial intelligence system as the artificial lighting for the photosynthesis, which includes the different wavelength of light needed by the lettuce to grow in a room or indoor setting using the hydroponic systems and a solar sharing environment. And last is to determine the various AM models, DLI, and PPDF in terms of coefficient determination and mean absolute value error. Methodology. So start with the um, with the PPDF and DLI, run into the puzzle logic that it leads to have the smart lighting systems. And the smart lighting systems controls have the microcontroller as Arduino, sensors, and the IoT. So we have uh, gathered data sets, and these data sets provide us different models for further evaluations. Here is the black diagram of the solar and AI-based lighting systems using the puzzle logics. As you can see in the diagram, we have the puzzle logic controller that has the falsification, the reading based on the knowledge base, and the falsification, which has the contribution of the daylight and the artificial lighting by its having the dimming level and driver controller to reduce the lighting control. It also has the illumination bulb and lighting references and sensors. The resultant discussion. As you can see in the datasets, the daily light integral of the smart lighting systems, as without the smart lighting systems, the DLI is uneven, or the distribution of light is not evenly proportional or for the needed light of the plants. And the next is the DLI with the smart lighting systems, evenly distributed the light with the different uh, stratums or layers. So we can say that the distribution of the light shown in the table is equally distributed using the smart lighting support. And the graph shows the illuminance performance of the control system for the smart lighting systems that has its photo period from 9 to 10 hours, different models that has its coefficient of determination of 0.99%. That means it is called strongly correlated. And we have the summary of determination of the different AI models. The model 1 has 0.9684. Model 2 has 0.9778. Model 3 has 0.9839, which shows it has a strong correlation with the numbers of date and rows of letters using the smart lighting, solar sharing smart lighting system. And we also have the growth performance in terms of its ends average mass measured in grams of the letters, as shown in the diagram that the Model 1 has 125 grams harvested lettuce. Model 2 has 253 grams. Model 3 has 325 grams. And 25 grams harvested in the controlled condition. And based on the cost-benefit analysis, the cost productions average from 10,845 pesos, and the annual gross income is 11,340, which has the 104 cost-benefit analysis. So in the conclusion, the coefficient of determination is about 0.96, 0.97, and 0.98, which is strongly correlated with each other. And the mean absolute error is 3.16, 2.20, and 1.61%. In the recommendation, it is recommended to add the nutrient management system. Thank you for listening. So once again, this Dr. Myrtle S. Bernardo from Bulacan Agricultural State College, Philippines. Thank you.